So today is Science Day, celebrated in commemoration of the discovery of Raman effect by C.V. Raman. But even though it is Science Day, I'm not going to speak anything about science today. But what I will be speaking to you about is how education can help us know better about science and how science education could be taken forward. So I will be speaking to you not as a teacher to a student, but I will be considering you all as the future educators. So this will be more like my experiences in teaching learning, how I have taken forward, or maybe how I have put into effect the things that I have learned from my gurus and my teachers in transacting science knowledge. So I would like to have some interaction from you all. And for that, the first question that I'm putting forward is, what is science? Can anyone tell me what science is all about? I would be happy to hear some responses.
Ma'am, science is about observing the natural phenomena and understanding the reasons for them.
Okay, so let's get to know what science is all about and how education can help us make learning of science better. Science, as described by the Science Council, is a pursuit and application of knowledge and understanding of the natural and social worlds. And it is the ability of people to use this knowledge to improve their lives. So science is not just mere some facts or concepts or hypotheses and theorems. It is actually the knowledge that helps us improve our lives and live better. So this itself brings up the question, why science education is important. As our Prime Minister Jawaharlal Nehru has put in, who indeed can afford to ignore science today? At every turn, we have to seek its aid, and the whole fabric of world is of its making. So this itself answers the question, why science education is important. Because wherever you go, whatever you do, in every aspect of life, we will need science and its application. So science, as we all know, and its application helps to satisfy many of the basic human needs. And that is why we cannot keep apart science as such. Say, starting from the production of food that helps us sustain, or finding a cure for some diseases, or just to have a clean energy for all our daily purposes, or even a clean environment. All these needs science. In today's world, where economics is very important, science is also regarded as a return on investment of public funding. This return of public funding is what drives the economic growth of a nation. And hence, the goal of science is to find a way of rationally using all these natural resources which will help us sustain in this world, or in other words, which will ensure sustainability. So science education, or addition of scientific knowledge to enhance education, is becoming more and more important because of many reasons. First and the foremost is that, as we all know, education is now considered as a human right. Every person who has taken birth in this world has a right to education. The next, we all know we need medical help, we need technology for our daily work, we need environmental applications. For all these, we need science. But science, we cannot just have science just like that, especially when we consider the field of medicine. We will not go to a doctor who is not professionally qualified. That means we need to have a formal education in science, and we need to have experts who can handle all these different technologies very efficiently to improving the living standards. So that is where science education comes in. So before we venture further, let's take a quick peek look at what happened and how the science education evolved across different centuries. History of science In a global view, we could say that it started way back in 16th century when Roger Bacon proposed the experimental methods of learning, and Francis Bacon put forward the possibility of scientific knowledge which is based upon inductive reasoning. So he stressed about the careful observation of events in nature. As someone spoke before, what is in nature, the observation, how we interpret, all these is culminating in what we call today as science. And many different personalities, great philosophers, and great scientists like Galileo Galilei, William Harvey, and Audrey Valliers, all these people have contributed in the growth of science and science education. They have worked in varied fields of science, applied science and technology. They have provided experiments and arguments to support their ideas. They have spoken about, they have worked with medicine and the practice of medicine, as well as they have revolutionized the study of biology by putting in experimental and cognitive analytical reasoning into what we call today as modern science. So, father of modern education, Comenius, he emphasized the importance of objects and pictures in teaching. We all know teaching today is not just a piece of cake, it is full of challenges. We come across children who are having different cognitive abilities. So, to cater to them, we need to adopt many different methodologies in transacting our knowledge. And in 1664, one of the landmarks in the history of science education was the establishment of Royal Society. And from there, the 17th century, 18th century, it all brought different revolutions in the field of science and brought science closer to the common man. And with the establishment of different universities, natural science was also introduced in the curriculum, and science, or maybe you could say that biological sciences, began to be taught in universities across the world. So these are all different people who contributed much to the to the dissemination of science education. And science as such was put into school curriculum for the first time by introducing different areas of science like botany, geology, physics, and astronomy at Rugby School of England. And from there, to the 20th century and now the 21st century, there has been a rapid propagation in science education all over the world. Speaking about the global view, we Indians are not far behind. We are known to have had the world's first university, Takshashila. You must all be knowing that it is one of the famous and one of the foremost universities to have been ever placed in the world. And the beauty of it is that even in that 6th century BC, our university used to cater to the needs of different people from across different continents, and 68 different streams of knowledge were taught in the university, which included many of the science streams, including medicine, surgery, and astronomy. Speaking about the development of modern science in India, we could say that we could divide it into two, like what science education was during the British rule and after the independence. So during the British rule, mostly the British people introduced science education mainly for making their work easier. Like they wanted to use Indian human power to help them run the whole show. So they did not very much think about how this science education is going to benefit the Indians as a whole. But at the same time, they did contribute much to the science education as we see today in India. Universities of Bombay, Calcutta, and Madras were established during those times, and foundation for all the basic sciences and the academic sciences in universities were laid during those times. Even at that time, we should be very proud that globally competitive research was carried out by eminent scientists like C.V. Raman, S.N. Bose, Birbal Sahni, and S. Chandrasekhar, even at those difficult times. And we should be saluting them for their relentless work in the field of science. And post independence saw a drastic growth in the field of science education. And as C.V. Raman has put in, there is only one solution to India's economic problems, that is science, and still more science. So, this word itself, or this quote itself, speaks the importance of science and how science has helped India's economy develop much faster and much better. So in 1953, Secondary Education Commission recommended teaching of general science and made it compulsory subject in all the high schools and higher secondary schools. And the national scientific policies took shape during 1958. In 1961, the Indian Parliamentary and Scientific Committee was set up under the leadership of Sri Lal Bahadur Shastri. NCRT, as we all know, it's a separate department of science education that was also established in 1961. And then came the Indian Education Commission, which made science teaching an important or compulsory subject as part of the general education. And it emphasized that science teaching should be linked with agriculture and technology. So just imagine how far futuristic thoughts they had when they were linking agriculture and technology along with science teaching. We all know we are adopting or we are using so much of scientific technology in the field of agriculture for producing food, and we are using technology for all the different things that we are doing on a day-to-day basis. Then there were constitutional amendments, establishment of the Ministry of Human Resource Development, then the UGC Grants Commission, All India Council for Technical Education. All these have played a major role in promoting science education in India and making India one of the topmost countries in the world where science, technology, and research innovations are going on at a very faster pace. We all know the role that UGC is playing in promoting science education and trying to transform our higher education institutions to institutions of excellence. We all know that they are providing fellowships, they are providing research grants, they are making curriculum amendments, then they are supporting autonomous colleges and faculty improvement programs, so on and so forth. So many programs and schemes are coming under UGC for promoting science education. And we as beneficiaries, we should be able to take all these up forward and make our own contributions in the pursuit of science education. Then the national policy on education at different times. The first one in 1968 under Prime Minister Indira Gandhi, and second one under the government of Prime Minister Rajiv Gandhi in 1986. All these different national policies on education had one major goal, that is, let the children play, learn, and grow together. So that is how they have envisioned the science education. Through play, games, we need to inculcate a scientific aptitude in the children so that they can take it all along throughout their lives and apply science for all the different areas of science, technology, and innovation. So this is just to show you the milestones in the evolution of national education policy of India. And ultimately, the latest one in 2020, all these has got their own good, their own bad. We are not going to take a debate on it right now. But only thing is, all these national policies have been envisioned with a single goal. What is it? To ensure universal access to education at all levels, making it accessible even to the remotest of areas, whether it is rural, whether it is urban. Every child has a right for education. So that is what the national education policy of India is all about. So, with all these things in place, how are we going to take it forward and make our students or our learners uh, suitable or impart skills in them so that they can be competitors, they can face life head on. So that is where quality science education comes in. And it is not just science education, it is not just the facts or the hypotheses or the theorems that we need to learn. We need to acquire the 21st century skills, which will make us leaders, which will make us go forward in the pursuit of science and science education. So Sun Kwok has said, Asian students can calculate very quickly and accurately, but they have no idea that mathematics is an essential framework for science. He also writes that they are able to derive complex equations in physics, but they fail to relate these equations to physics of nature. And this is something serious that we need to uh, take into consideration. Me included, at many times, what we do is when we are learning something, we learn it just for the sake of academic exercise, just for the sake of exams. Do we understand the whole thing? Are we trying to comprehend the whole thing, or are we trying to put it forward, or are we trying to implement it in our lives? Are we trying to correlate it to what it is actually? Are we going back to nature and seeing and observing and comprehending what this is all about? Many times we fail. So the most important thing is, it is not how much science we learn. What really matters is how we connect the science that we learn to our lives and to the society. So, to make this possible, we need to inculcate in us so many different skills that will make us equipped for understanding all these intricacies and fascinations of science in nature. So, the best thing is catch them young. So, as research suggests, children form an aptitude towards science, whether it is positive or negative, by the age of 7. And this aptitude that they gain at the very early age of 7 is what is mostly going to remain with them throughout their lives. So, we need to delve on this thing. That makes it very clear that schooling is not just a game that is to be won, but it is a road we need to choose very carefully so that it can lead us to intellectual fulfillment. So, how can we do this? We all know that children are very curious, they like to observe, they like to question. Many a times, as adults, especially in this modern era, as parents, as sisters and brothers, we seldom give them the time, we seldom give them a patient hearing to answer their queries and be with them and encourage them. But the ultimate thing that we need to do, the most important thing we need to do if we want to nurture in them the positive attitude towards science is encourage their natural curiosity, foster their investigative skills, stimulate the scientific thinking. How can we do this? By simple activities, through simple activities in nature, we can introduce the scientific concepts to their young minds. And those scientific concepts that we have given to them at a very early age, sure that is to remain with them to the rest of their lives. And as we all know, there are two phases to science. Science as a process, we all know, and it needs justifying the knowledge. And science as a process of discovering knowledge, that is how we know. Just listen to what Sana Samir has to say, and she, through her little speech, will give out to you both these phases of science as justifying the knowledge and discovering the knowledge.
My name is Sana Samir, and let me tell you a bit about ocean acidification. Ocean acidification is the ongoing decrease in the pH of Earth's oceans caused by carbon dioxide gas from the atmosphere dissolving into them. Ocean acidification binds carbonate ions, reducing the amount of carbonate. This makes it more difficult for marine organisms such as coral and some plankton to form their shells and skeletons, and existing skeletons may begin to dissolve. Notice how the shell in saline water remains intact while that in acidic water has dissolved. Currently, burning of fossil fuels such as coal, oil, and gas for human industry is one of the major causes. We can effectively limit ocean acidification by acting on climate change, implementing solutions to reduce the use of fossil fuels. If we implement solutions to reduce our global warming emissions and limit future warming, we can significantly reduce the harm brought upon marine organisms. Thank you.
So this is Sana Samir. She is my niece, and this simple experiment that she has conducted, and this is a video that she had created for her Science Day program in school. Now that it is online, this is how she has joined in the celebration of Science Day. And I'm sure that with this simple experiment that she has, a friend of her, she will never forget that acidification can cause dissolution of this calcium covering of all these marine animals. And it is like these, through these simple experiments, that we make an impact on the young minds, and we instill in them the scientific concepts which will remain with them forever. And we as educators has been doing so many science promoting science education workshops and activities. And these are all photographs from KKTM Government College, where I was working earlier. We used to have UGC educational innovation programs, wherein we used to conduct a series of hands-on workshops for school children, especially the children of government schools, calling them to the college using our infrastructure, our labs, and our expertise to help them understand the intricacies of nature. We let them open all the lab areas and all the little things that we could give them to make them understand the different fascinating features of science learning, and we could motivate them to observe nature very closely. So these are some of the glimpses from the hands-on workshop series for school children we had. And this lady here is Fenil again, an alumnus of Karivatam Botany Department. And this is from the demonstration workshop for school children during the Shastriyan program of Government of Kerala for promoting science education again, where we had children from across different schools coming over to our labs, and we could demonstrate to them simple experiments and even biotechnological experiments to invoke motivation and interest, to instill interest of science in them. And with this, we should also remember one thing. There is always a dynamic nature to science. That means there is always change. There is a constant revision. There is always a re-evaluation of existing knowledge. We know every day science is developing, technology is developing, so we get more and more new evidences, and because of these evidences, we need to challenge the validity of what was there before, and we need to change. So as science educators, this is one thing that we should always keep in mind, that we should convince our students that change is a normal element in scientific knowledge, and we need to adapt and adopt these changes so that we can go forward. So how do we do that? For this, we need to redefine the broad skill sets that the students require to participate as well as to contribute to today's society. So there has been a rapid change in the world all over, in the field of technology, scientific innovations, globalization. Then there is a shift in the demands of the workforce as well as economic competitiveness. So to face all these, we should equip our learners, or we could equip our students and the future educators with certain fundamental sets of essential tools. For example, language skills. There is a saying that we don't need language or grammar for science, but personally, I don't uh, agree to it, because language is something which helps us communicate with each other. Unless and until we have language command, we have vocabulary skills, we cannot comprehend or we cannot express our ideas or communicate our results to someone else. So, as learners, everybody should take care that we improve our language skills. Then, what we need most important in the pursuit of science education is quantitative skills. Science needs keen observation, ability to find out what is hidden behind something, then identify the variables, analyze the data that we have out of our experimentations, then, of course, to formulate solutions to problems. So, both these skills, that is, the language skills and the quantitative skills, hand in hand will equip our learners to have the fundamentals and to be there in the pursuit of science. So, as educators, our main goal should be to train students as people of intellect and not just people to get a job. That means not just for a vocation. We need to develop in our students a sense of curiosity. We should give them confidence to ask questions. At this point, I would like to say that I used to be a very reserved person before I came to Karyavatam. And the education and the time that I spent in the department has given me a drastic changeover, or maybe I could say that a makeover in me, uh, especially with our teachers always urging us to ask questions. But at those times when we were the PG students, we always had an inhibition. We were not like opening up and asking questions. But now I realize that now that I am an educator, still am a learner, the need to ask questions and to encourage our students to ask questions, that courage and confidence has come into us because of our teachers who has always instilled us in us the need to ask questions, so that we could challenge assumptions, we could start thinking analytically as well as quantitatively. And above all these things, the most important thing that each of us in the pursuit of science should have is an open mind to accept things, to accept the things that others are telling us, whether it is right or wrong, that is a different story. But the first thing is listen, observe, analyze with an open mind, so that we will come to a definite conclusion. And we should be able to remain independent from public opinion. We all know that there has been so much hue and cry about biotechnology, transgenics, so on and so forth. Unless and until we know what is the basic science behind all this, we should not have an opinion about all this. So that is what I'm saying. We should have an open mind so that we can comprehend things properly. So, as I said earlier, if we are giving all these skills to our learners, we as educators will be able to produce graduates who should be versatile enough to take any sort of job. So, that means they can apply what they have learned in different fields of life. It's not just in the field of academics or research, they can also venture into diverse, innovative areas. What you're seeing right here on the left hand side are three distinguished ladies. They are all well educated, they are all well placed in different universities across the world, but they have come together to start up something known as Shoots and Roots Bitters. What they are doing is they are applying what they have learned. They are using their experiences in botanical diversity to create certain things which are like making use of what we have learned, or maybe realizing the things that we have learned and bringing it out as a product. And on the right hand side, what you're seeing is a new entrepreneur, one of my students from KKTM Government College. He's a new entrepreneur. He has started using the knowledge he has gained in horticulture and breeding to start up Uonia Greenery, which is a venture dealing with indoor and outdoor plants. So these are just two examples of what we can do if we are in the right path of attaining science education and taking it all up with an open mind. So science education, as we say, should lay the groundwork for lifelong learning. As I said earlier, dynamism is the nature of science. That means it is not stopping anywhere. Day to day, it keeps on improving, it keeps on changing. That means the societal needs are also changing, so we need to adapt and adopt. So several topics which once used to be taught in universities and schools may now seem obsolete, but we need to incorporate them and find out their applications and introduce new innovative mechanisms of teaching and learning, maybe by introducing some visuals, giving more emphasis on practical knowledge and fact finding. So these are all needed for the science pursuit in the modern world. So how can we do all this? We can prepare students as holistic individuals who can think independently, analytically, and try to solve problems. So these are all, again, glimpses where the students were put into task, where they were using their science education for the well-being of society. This is from an Environment Day celebration. And again, to improve their communicative skills. As I said earlier, language is very important. If you have language, that doesn't mean it ends there. We need to have the courage. We need to have the guts to speak. We need to have courage to face an audience and express our ideas and communicate with people. So that is, again, what we are trying to inculcate in our students through a concept known as student tutors. Through across different programs that we have in colleges, we encourage our students to come up front and take up presentations, maybe even in small areas, but still we motivate them to come up and speak. So again, we provide opportunities for students to engage in research and practical exercises. So in KKTM Government College, even though it was just a UG department that we had, botany department, we used to be very dynamic over there, giving obtune importance to practical know-how as well as research. And we always try to inculcate in our students a research aptitude, a scientific aptitude, by making them part of all the training programs, be it a workshop, be it a seminar, be it an exhibition. We made them work. We made them be part of it and have an inquisitive nature. And you can see over here, this is from one of the workshops in phytochemistry, and these are all my students. And this is again Dr. Nessie, again an alumnus of the department. She is the head of the department and principal in charge there. And these are all from glimpses from different national UGC seminars where our students are presenting their research findings because they have project work during their UG programs, and these are all hands-on trainings that are being given to them in various aspects of science. Again, we provide opportunities to interact with a community of scholars, and this is when Dr. G.M. Nair sir has visited our department for UGC seminar, and this is my student. She had presented a paper during that seminar, and these are all different activities that we are inculcating in our students whenever we can. And again, to making learning of science fun, we introduce certain small projects. For example, one that you are seeing over here, Know Your Campus Greens, was a venture to bring the students to learn taxonomy easily. So they were given tasks to identify plants in the campus, and they were put in charge one student. And here the student tutor was called the green teacher, and that green teacher was to introduce the plant, their uses, their scientific nature, and all that to the crowd. So it was an open project, and all the other people, the teachers, the faculties, the students from all the departments would come and take part in this Know Your Campus Green. So it was one of the success stories wherein we could inculcate a feeling of fun learning of science. And we had some other projects like what is that? New day, new plant, wherein every day a plant will be introduced. And again, we had a concept of having a taxonomy garden wherein the students were actually maintaining the garden by collecting plants belonging to the taxonomic families included in their syllabus, so that they get to know, they get to familiarize with the plants, the families, and the characteristics of that plants. And we had a concept of maintaining the specimens as far as possible in the live condition in the form of a live museum also. So many of the specimens which I had during my years of learning seen only as preserved materials, we could put forward to our students in a live manner. So that is again one of the fun things that we used to do to motivate our students in science learning, and to provide broad academic background in all the fields of science. These are all glimpses wherein it is all participative and inclusive things that we do over there. We introduce them to many different areas of science. You can see here, this is a visit to BSI. This is Rakesh again from the Department of Botany. And this is Arya. She's demonstrating a horticultural process to her colleagues. And this is a visit to the cotton breeding station. And again, phytochemical things, how to use a Soxhlet apparatus and so on. Then this is in microbiology, and this is again drip irrigation, that is part of horticulture. So all these things we do in colleges to make students interested. And again, these are all again glimpses wherein we try to expose students to the diverse academic training that is beyond the classroom and the laboratory, out in the wild. Go explore. So that is the ultimate aim. So speaking about all these, with the developments in the digital technology, there has been a drastic or dramatic change in the field of education. We need to innovate teaching methods. As educators, we need to adapt. So shifting from the traditional blackboard teaching to the ICT-enabled teaching, and now recently to the online mode. So there has been a massive shift in the transaction of knowledge, and with the introduction of MOOCs, which is a massive open online initiatives, there has been a change in the comprehensive educational format. And innovations again in the form of virtual labs, where we do what do you say, an inductive labs before the actual wet lab experiments. Then again, MOOCs. Here, this is Vivek again from the Department of Botany. And lately in Maharajas College, we have come up to the digitization of the garden, where with the help of Ganga Prasad sir and Akhilesh, we have digitized the trees, and students have now been exposed to the digital world where technology and innovation can be incorporated into the learning as well as teaching of science. What does all this mean by? We as educators also has to move forward. We need to educate educators. We need to adopt, we need to move forward as the demands of the society and the ages. So I myself is not a tech savvy, but need came when I need to shift from the ICT mode of teaching, learning to the online mode. As you all know, because of this pandemic, we need to equip ourselves with the techniques and the tools of online teaching learning. So we had to undergo training ourselves as teachers, and to make things more clear, or maybe as we say, the more we share, the more we gain. So with what I had learned, with a pool of friends together, we had also conducted an online teaching learning for beginners, an FDP course for teachers again, for educators, and I took a small part in introducing the video editing software over there. So what I'm trying to emphasize here is that what I said earlier, we need to have an open mind. We should have an open mind to adopt as need be. We need to shift. We need to innovate. We need to be moving forward in a progressive manner. So exemplary science education need to instill in the learners critical thinking, problem solving ability, and information literacy. With all these skills, what are we doing to our learners? We are providing them life skills. I always keep telling my students, we just don't teach you science, we teach you life skills. So whenever we are having all those programs we are conducting for our students, we are instilling in them so many different life skills, starting from how to organize, how to have a teamwork. Without teamwork you cannot achieve anything at all. How to comprehend, how to have a problem solving ability if need be, if a emergency comes, how can you handle things. So all these life skills are also being imparted to our students through science education. And with this, I would stop my words over here. And I would suggest that being the next generation educators, a friend of me, you are the people to keep science alive. So become that scientifically literate person. Inculcate in yourself all these skills as much as possible. You are all fortunate enough to be in a department which is always nurturing their children, their students in the best manner possible. And I myself is a part of the department, and I know how much my time in the department, my teachers have transformed my life to what it is today. Thank you so much, and good luck, everyone.